Welcome to topic 1. We are going to be looking at interpreting key features of linear, quadratic, and absolute value functions and applying transformations. So we have some basic stuff here and more there, but we're not going to get into that yet. So our prerequisites or our intro to topic 1 is basically doing stuff that we've already done, things that you've already learned. So given the parent function, which is this, complete the table and graph. Use inequalities to state the domain and range. Use coordinates to give the x-intercept and the y-intercept. So we're not using calculators or Desmos or anything like that. We're doing this by hand. So remember that f of x is really y. So if we substitute in -2 for x, well then y equals -2. If we substitute in -1 for x, we get y equals -1. It's going to be like this. This is our identity function. It's also linear. So we plot those points. Maybe a couple more if we see the pattern. We keep going. Connect them all. Make sure we have the arrows on it because it goes on for forever. So there is our graph. Pretty straightforward. Our domain, it's all possible x values. Well, our x is on our horizontal axis here. Let me highlight that. And so this pink line goes all the way to -infinity on the left. It doesn't stop. It just keeps going. Same thing on the right. So, I believe what we were used to last year, our domain would be all real numbers. You can put in anything for x. That's all that's saying. Our range, well, it's the same as the domain because y equals x, they're the same. So it's also all real numbers. And that's because this graph keeps going up to a positive infinity forever and down to -infinity for forever because it's a line, it doesn't stop. Our x-intercept and y-intercept are both 0, 0, our origin, because that's where they cross the x-axis and the y-axis. So that's our linear function or identity function. Here we have our quadratic function. Quadratic, which means squared, not 4, even though it kind of sounds like that, it's squared. So we have our x squared graph. So if we were to substitute in, again, make g of x equal to y. So y equals -2, we're plugging that in for x. Squaring it, that'll equal y, and that's +4. Same thing with -1. -1 squared is +1. 0 squared is 0. 1 squared is 1. 2 squared is +4. So you guys should have dealt with a lot with quadratics last year, and therefore it should look like this, give or take. Hopefully better than what I got going on. That's our quadratic. Now again, our domain, well, this goes all the way to the left. It goes all the way to the right for forever. So again, it's all real numbers. However, our range isn't now. It keeps going up for forever, but it doesn't go down for forever. It stops. There's a stopping point right here, or specifically there. So we don't have any y values that are less than 0. So all of our y values are greater than or equal to 0. It's 0 and up. Our x-intercept and our y-intercepts are both 0, 0. That's going to be the same for most parent functions. So remember that. Then Moving on, we have our absolute value function. Should have done this last year as well. Remember, that's a V, absolute value. It looks like a V instead of a U. But we know when we substitute in -2 for x, the absolute value of -2 is 2. Absolute value of -1 is 1, 0, 0, 1, 1, 2, 2. So it looks very similar to our quadratic, except the sides are straight. And again, our domain is going to be all real numbers. That'll be for most of our functions. Our range, again, is starting at 0 and it's going up. So it's y is greater than or equal to 0. X-intercept and y-intercepts are both zeros again, because they both cross right there. And then one of the easier functions, I like it because I'm lazy. This now says y equals 4. This is our constant function. It's constantly the same number. 4. Y equals 4. That's what it says. No matter what you put in for x, y equals 4, y equals 4, y equals 4, y equals 4, y equals 4. So we can graph those points, and you can see it's just a horizontal line. Make sure we have arrows on the end to indicate that it keeps going on for forever. So our domain, we're looking left, we're looking right. Well, it goes on for forever, both directions. So again, it is all real numbers. Now our range is not all real numbers. It's not even a range. Our range, or the values of y that we can have, are all right there. Y equals 4. That's it. That's all y can be. Our x-intercept, we don't have any, do we? This line doesn't go up or down, so it's just going to keep going, and it's not going to intercept the x-axis. The y-axis, yeah, right here. So the y-intercept would be 0, 4. Now, any of you keeping track at home realize I did not graph that right. Should be at 4, not 2. I apologize. It is still a horizontal line, but it's up at 4. So nothing else changes. I just graphed it wrong, unfortunately. So those are the functions that we need to know, that you should know before coming into this class. Then evaluate each expression. So now we have fractions, and we can't use a calculator. So when we add fractions or subtract them, we need to find a common denominator. So we need the smallest number that 4 and 2 both go into. Well, 4 goes into 4, 2 goes into 4. Nothing smaller than 4 will work. So we got 4. So 3 over 4 is still 3 over 4. But to get from 1/2 to something over 4, we multiply the denominator by 2. Obviously, 2 times 2 is 4. And 1 times 2 is 2. So 1/2 is the same as 2/4. And then we just add our numerators. So 5 over 4, or 1 and 1/4, or even 1.25. I don't care which way we write it. Number 6, same idea. Our common denominator would be 6. The first fraction stays the same. Second one, well, we're multiplying by 2 again. So 5 minus 2 is 3 over 6. And of course, we can simplify that by dividing both by 3. So we get 1/2 or 0.5. Again, does not matter which one you use. Now, number 7 and 8 are very, 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 very important, because we're going to make mistakes on this all year round if we don't take this to heart. Now, number 7 and number 8 are not the same problem. Number 7 is saying, hey, raise 2 to the 4th power and then make it negative. The exponent acts on the thing right in front of it, which is just the 2. To get the negative in there, we need parentheses like there is in number 8. So this one would be negative, and 2 to the 4th is 16. Whereas if we do negative 2 times negative 2 times negative 2 times negative 2, we get a positive 16. So where that negative goes makes a big difference.